sometimes. Okay. I was about to stop it and restart it, and it had already done it. Okay, so complement is a fancy word for saying not or whatever. So it's like, if one of them is, oh, Merced makes $1,000 tomorrow, the complement of that event is Merced does not make $1,000 tomorrow. So that's probably more probable than the event itself was. So the complement, so 15 athletes are tested, none of them test negative. So the complement would be at least one of them test positive, right? At least one of them. Wow, it's not there. I mean, I would say at least one instead of more than one, but that's closer than any of the other ones are. Well, C says at least one test negative. Yeah, I mean, it's.
Does it have to be something that's positive?
Complement. Oh, crap! It is C. I can't read. So none of them test negative. Is they all test positive. So the opposite of they all test positive is at least one of them tests negative. Wow. Okay. I can't. Yeah. English is not my strong suit. Let's do another one. Okay. I guess they're not going to. All right. So the probability of being a girl in one country is 0.475. Among the next 8 selected births, what's the probability at least one of them is a boy? So doing this the direct way, like saying, okay, well, that's close. So that's the probability of getting one boy. We want to say, okay, there's 8 selected births. What's the probability of at least one in that group? Right? So let me tell you how you should not do this first. So if my pen will start writing. So the probability of at least one boy. Well, you could do the or thing. So this is first boy, or the second one is a boy, or the third one is a boy, or ... up to the 8th one is a boy, right? Which, well, it's just like when we were doing or before, we would do the probability on the first guy, probability on the second guy, up to probability on the 8th guy. But then we'd have to subtract off the probability that the first 2 are both boys. And also the probability the first and the third is a boy. And also, this is the way not to do it. So basically, if you try to do this directly, it's just hard because you have to add up each single, subtract off each pair, then you subtract it off too much, so you have to add in each triple, subtract off each 4, add in each 5, subtract off each 6, add in each 7, and then subtract off all 8. Sounds like a lot of work, don't it? Yeah. So let's not do that. So the other thing would see is to say, so at least one boy, the complement, which they write with just a bar, is all girl. Right? So if we wanted to find the probability of all girls, well, now we're doing, this is the probability of first and the second and up to the 8th are all girls. So for and, it's easy. You just do, the probability the first one's a girl times the probability the second one's a girl, given that the first one was, the probability of the third one, given that the first 2 were, But I mean, they're all independent, so you don't really have to do that. You just say, oh, this is the probability the first one's a girl times the probability the second one's a girl. I have no idea why this thing hates me. So probability that the first one's a girl times probability of the second one being a girl up to the probability of the eighth one's a girl. Again, this is just because they're independent. Normally, you'd have to think, okay, what's the probability the second one's a girl given that the first one was? But anyway, so that's just 0.475. They're all 0.475. So 0.475 to the eighth. So that's the probability of getting all girls. And then if you want the probability of at least one boy, do 1 minus that. This is probability of one or more boys. Okay, so 1 minus 0.475 to the eighth. So we got a pretty good chance of having a boy in there somewhere. No. 30 seems like a good place to stop. Let's do this one and call it a day. How's that sound? Are you in favor of that, JP?
I'm good with that.
You're good with that? Okay. Assume one individual from the group is randomly selected. Find the probability of giving someone who tests negative, given that he or she had the disease. So this is, they're asking for conditional probability. So they want to know what's the probability that you test negative, given that you have the disease. Okay. So the individual actually had the disease. Yeah, it's the 26 out of just the 26 and the 122 together. So we completely forget about the no column because we're given that the person actually has the disease. Well, 26 over 148. And I need to put it over all the people who have the disease. Right. So, yeah, so the negative that had the disease was 26. And then divided by everybody who had the disease, which was 26 plus, what was it, 122? Three decimals would be a 6. Cool. All right. I think that's probably good for today. Yeah.